cloud, which is serverless. Right? It's on everybody's mind today. And if you're not familiar with it, serverless is this compute abstraction that takes away all notion of infrastructure from you as a developer. Right? It applies to many things. It applies to compute, to databases, to storage. But importantly, when we talk about applying serverless to our code, to what we deploy, we think of it as functions as service. Right? And it's kind of a beautiful model, right? Because it lets you focus purely on the logic of your code, purely on business logic, not worrying about infrastructure, not worrying about that like muck that's in your system. And importantly, it gives you an amazing economic model too. But again, having worked in the cloud space for a while, you look at this, and honestly, where we are in the space of the industry is actually pretty nascent, right? What's out there today is literally triggers for the cloud, right? Every cloud provider's got one of these things. Something like a VM goes up, a VM goes down, it publishes an event to a bus. You get some code that executes. You can take some action. It's super helpful. It's amazing for that use case, but it's easy to be tricked into thinking that's an app dev platform when it's not, right? The fundamentals of computer science are always with us, right? Things like concurrency and synchronization and state management. These are hard. For any reasonably sized application or reasonably sized microservice, you need something better to do that. What you need to solve those problems is what Java was invented for in the first place, right? You need a language. 22 years ago, Java solved this problem. It's why it is where it is today for running on top of an operating system, whether that was Linux, Solaris, Windows, whatever. When we talk about the distributed operating system, right, that going to the cloud, we need a language to help us with those problems. So we're super excited to talk about what we're doing next. Right, we're going to talk about an open source project we're creating that is container native, completely language agnostic, but there's importantly an exciting Java layer that we're putting into it to solve those problems. So what I'd like to do is turn the stage over to Chad Aramura from my team to talk about what we're doing. So Chad, the stage is yours.
Thanks, Mark. My screen. I am super thrilled to introduce to you the FN project. The FN project today consists of 3 components. Number 1, the FN server. The FN server is the foundation of your functions as a service platform. It's what enables developers to build, deploy, and scale functions in a multi-cloud environment. It runs locally on your laptop, so you can get dev prod parity working locally, both in the cloud. It's fast, scalable, and container native. Number 2, we're announcing the FN Java FDK, or Function Development Kit. The Java FDK allows you to easily bootstrap your Java functions. It gives you a data binding model to bind the input to your functions to common Java objects and types. And finally, we're announcing the and finally, it gives you a test harness to test all of your functions using JUnit rules. So I don't want to forget that. And finally, we're announcing FN Flow. Flow is a system that enables developers to build higher-level workflows and orchestrate your functions in a more complex environment. You get things like sequencing and chaining, parallelism, fan-in, fan-out, error handling, state management, all from the language of your choice. Today, of course, we're announcing that Java is the first officially supported language. That's actually what I'm going to demo today. So in order to show this, we built a demo app called Vista. If you look at this application, it consists of 5 functions. And basically what it's doing is pulling images from Flickr of cars, detecting the license plate on that car, getting the actual value of the license plate using the OpenALPR library, which is an open source library. And then it uses OpenCV to draw a box around the license plate and send all of that information to both Twitter and Slack. As you can see, we have a number of red arrows here. And those are no-nos. That's where we have hard-coded invocations of each function from the previous one in order to call them. It's almost an anti-pattern when it comes to microservices and functional development. Enter FN Flow. FN Flow gives us a programmatic way to remove those hard-coded invocations and move them into their own function called a flow function. What we've done is decoupled all our functions from each other, and now we're back to the proper architecture for functional development. Let's take a look at some code. The first thing we'll notice here is that it's short, sweet, and simple. It's really a great thing. If you look at the top, we have our scraper that we invoke. There's a little lag here. Once we invoke the scraper, we get back a flow future object. That flow future object implements the standard completable future API that was introduced in Java 8. Along with that API, comes a number of promises-like methods that gives us all the nice workflow that we want, such as then compose. Then compose adds steps to the compute graph and returns a future that represents the completion of those steps. Once we do that, we get basically the nice fan-out capability that I talked about before. So then we fan out, and we run the plate detection, and we also run draw. And once we're finished with that, we run all of, which gives us both the Twitter and the Slack function, which posts to those. And when it's complete, we have a when complete method, which then tells us whether it was successful or it failed. That's actually something that I had no concept of before in the first version of Vista, because we had no concept of a complete workflow. So a couple things I want to point out. Of course, this looks like a single Java program. In fact, it can be reasoned about just like a single Java program. We can test it. We can use JUnit. We can put breakpoints. We have our familiar IDE. It's a single function code base. But behind the scenes, it's being broken up into sometimes hundreds, if not thousands, of function invocations. In fact, every step is a different JVM that we're running in a massively parallel environment. So you get all the benefits of a functions as a service system, such as the economic model of only getting charged for the milliseconds that these things are running, massive parallelization, and also the operational benefits without the complexity of dealing with a functions as a service system. And one other thing to note, any variables that were created inside the enclosed scope, whether part of the heap or the stack, gets reconstituted in all future invocations of any functions inside that scope. So it's a very powerful concept that no other workflow system gives you today. So I quickly plugged in the internet right as I came on stage. So we're going to see if I have internet. But we're going to try and run a demo. Yeah, I was on the Wi-Fi before. Don't ask me why. So if you look here, all I have is a simple payload.json file. It's just your standard JSON, 3 input variables, license plate, car USA. We're going to pull 20 of them. And because FN, the functions actually take standard in as their input, it's very, very simple. I can actually take that payload, and I can pipe it right into FN call. FN call is a wrapper around curl, which hits the server, which in this case happens to be running locally on my machine. And then my app name is my app, and it's flow. So once it starts running, the first thing we'll notice on the left is a number of functions are starting to spin up. We see that we already have a couple running. We have a number complete. And in the middle, this is the flow UI, which shows here, I'll make this big, which shows the fan out. So at the top, we have, let's make this bigger. We can see now we're starting to fan out. This is a visual representation of all of the functions that are being sequenced and ran from each other, including a nice fan out capability. If I click on any particular node, for example, this one, I can actually view the entire call stack of how this particular function was called. This is really extremely powerful. It was composed from detect plates. Here's the log that I got from detect plates. I can view all the way down to the scraper, which is what the first function is in our sequence, all the way down to the flow function. And if we look on the right, of course, it's already finished. I wasn't able to show much, but we get all of our images in Slack, and finally, it's finished scraping. So I know this demo is extremely fast, but I hope that you got to see just a sense of how powerful the FN project can be and why we're so excited to announce it to the Java community today. Thank you.
So Chad, before you walk off stage, I actually have a question. This is going to be open source, right?
That's the plan, Mark.
Is it open source right now?
It isn't.
Well, it probably should be. Like, we're JavaOne. I say we do it.
Let's do it.
All right, open source the FN project right now.
Oh, there it is.
Here we go.
All right.
It's like we knew this was going to happen.
Well, I'm in the danger zone. All right. Hopefully my two-factor auth is off. Oh, no. Wait. Don't worry. That's an advertisement for 1Password. Boom. It's open.
It's open source right now.
Thanks.
All right. So please go try it out. We're really excited about where this is going. fnproject.io, by the way, if we didn't say the name. So please come try it out. Please give us feedback. Please come participate in it. Now, one thing I want to say about this, like the last thing I want to say on this, Chad showed you this demo. It's a super amazing demo. I get chills every time. But he talked about the completable futures API, right? And I think the way to think about this is, think of this as like a V1, right? This is our first step. When we talk about setting up Java for the next decade, imagine what we can do when we actually apply the language to this in a much bigger way, which is actually an excellent segue to the next of our talk.